So in this video I want to show you what happens on the very first unpacking. Cloning the kernel takes a lot of time, especially if we don't do it like in a very shallow clone. And here it's from today. I just cloned the master. Of course I can check out with my build system the corresponding tree, but look here, the head of the tree is 6.17 RC2. What I'm going to do in this video is show what's happening when I literally clone everything like kernel busybox for the first time, and I will show you how things get populated like as we go. Okay, so I will, now it's already building the Linux kernel. I do it for several architectures. This is like the i386. In previous videos you could see also some of the logs where everything was built already, and maybe we added some vert.io constructs to it. But if we look at the tree a little bit prior to it, like only when we started compiling, then I started on a new folder deliberately. Here I put the TMP and this temporary persistent storage all under the same folder, so that it's easy like to look at the structure without additional command. And basically under TMP we'll have temporary stuff like the log. Under build we have what is shared, that is src, that is like source, like Linux kernel source code, busybox source code, and things like that have nothing to do with architecture. And per architecture we'll have like things that are more specific, like busybox build and Linux kernel build. Then on the build target product we'll have things that are specific to the specific build, like PscgBuildOS for build i386 in this case, and then there are also like the subfolders, and like for the Debian ones. So if we do like an entire tree, now the kernel is building, okay? And this is now the default configuration, which is also a motivation for putting slimmer kernel configuration, which I have done in several videos, and I will likely publish it. But I'm just going to start it. It's an RC kernel. I'm going to try to start a build with the defaults. Let's see what's going on there. Okay, just warning, all of the architectures nowadays, as opposed to like 3 years ago where you could build for RISC-V and it would be blazing fast, all of them have quite bloated def configs, which is a bad sign for us hackers or developers because we want to build fast. But it's a very good sign for the overall consumer community, because it means there is more support for more peripherals on more real boards. So the idea is that, like, if I now go just for fun, let's see how big everything here is. I want to do du, of course, and not sudo. So now it's like 2.3 gigs over there, okay? Meaning that the kernel code itself goes into another place, like the kernel caches and like the other caches that I mentioned. In which case did they go? They go to the same place that I did like in the previous video, and this is like intentional. So if we now go and look at PscG build caches host, then it will be much bigger, okay? So here we have these things here, and we have the downloads here, where we're going to have the Linux kernel as well. Sounds familiar, right? Looks familiar. All right. And that's basically where we did like the fetching and downloads here out of convenience, because then even if I want to like delete all the builds but I still want the caches to be separate, then I have them and we'll cover the other caches enough. So now downloading the Linux kernel took a long time. I didn't pass you through this. Downloading of course takes time, but once you've done that you're pretty much fine. And if we want to look at the different tasks. Okay, now the kernel is going to finish. So let me maybe do tree like super fast. This is another one. too many terminals. Yeah, I know. Oh, that's where I wanted like to be. So if I do 3 to, let's say, I call it aug19, without the levels, then I will of course have a lot of things. Okay, and all of these are of course the kernel ones. So let's go back to and let's see if we see something interesting here. Still building. Okay. So let me pause it. Now resume after like the first architecture. But not before. I'll go and just get like to this directory, forget about the Trixie or whatever. I'll go to build here, target, product. We're already building the next architecture, so here we see what's built. This is busybox, okay, the installation. Image material worked here. Installables, ext4 is where we'll have our system, and here we can see that it is relatively small because I put busybox there. It could be much smaller if we didn't have like all kind of like other things like ext4 file system and so on. And I can just repack it like myself, or I can just even like find the RAM disk that has been made and run it and run the kernel with it, and that's what I'll do before like I'll break the video. Right now it's building like the next architecture, but what I did want to show you is what happens like in a build log like for each like architecture. So for the very first one, this is already, I'll start with the second one actually. So for the second one, we go ahead. Yeah, just go from the log. I mean, it configures busybox again. That's fine. So I'll go and I'll cut aug. That's how I call it. Without most of like the kernel output, like mostly my logs are there. So we can see here that I have like, okay, welcome to the builder and so on and so forth. And I think I changed things between like different builds, so I need to see if I have another welcome to the builder. Yeah, so this is the first one probably. Okay, so what we have here is some initializations and some checking. It's cloning. It's trying to do here get busybox like for the very first time. Okay, this is like for it should be like either for the RAM disk task or something like that. Okay, this is the output directory actually. It creates the folders, and then the task here would be getting the Linux kernel. Forget about remove if exists. It's all kind of strategies of what I do. So these are some preparation like at the beginning, and then we have like the tasks. So the rootfs here would be built on busybox and just like repacking it. And so if busybox does not exist, we need to get it into caches and download it. This is what I do. I can do it from Git, can do it from tarball. And then we have the kernel, and this is the cloning that I've shown. So for the first time, we need to actually get the source itself. So you only saw the end of it, but like it took a couple of good minutes, say from 15 seconds to 41 seconds, to get the source code. This is why doing it over and over again is probably not so ideal, but I just took the latest and greatest now and cloned everything into like the source directory, because I want to be able to use different branches, different tags, and so on. However, for the particular builds that I have. Okay, for this I actually go and say, okay, I will not infect this, so that I can just even go and pull and rebase it all the time if I want. I will go and take like the local one that is for my build, like in this case under August 19 PscG, target shared src because these are source files. And obviously it's the same head here, but this will take much less time, of course. Look at it, it's nothing. And then this is like a first build. These are the configuration options that I added to it. I like to minimize the configuration, but I already talked about it. Then I installed the system. Here init rootfs would be using the same busybox stuff. And essentially the rootfs will also use the same busybox stuff. And that's it. There are imaging that I did not include here because my goal was, I just took, like in the previous video, I took a new Debian system, and I saw, okay, the greatest Trixie is now out. Let's see what's going on with that. Let's see what's going on with SID. And now I'm also taking like a newer kernel. So that's it for the first product. Now the next product would be an x86-64. Later I also do ARM, RISC-V, and so on. And here some of the steps will be skipped. So let's see, rootfs prepass. We don't need to do too much. Here we can see that the downloads here, busybox git existed. So there is a strategy if I want to refetch, to not, to delete, but I'm not. And here again, like I could go and use like a very specific one, like on the shared src, very specific commit. But if not, we're all good. We're just going to use that, and that's it. And for the kernel, again, we will see that we already have like the kernel in the src. And other than that, then basically these are like the configurations, okay? But basically, like for the fetch, it will also say, hey, the kernel git for like the common caches here, it exists, so I don't need it. And since this is like the src exists and is its source, I don't need to do anything. For the build itself, I do need to do. Now, what I explained like in the past is that if you want to modify your kernel in these mechanisms, and you have like shared src, then you need to know what you work on. And then you can also, we have like an option to separate it, but I usually want to build the same kernel for every architecture that I have. Otherwise, I will have like a different working tree, and I will know what to do, and so should you. You cannot win everything. You need to like choose. It's not like exactly the battles, because it's something positive. So then again, it's build, and so on and so forth. This was like from the previous one. Now let's see, maybe I'm on the next architecture already. So so yeah, so this was the things that I have been building. There are several things here that are built. If I look at the tree, it will be much, let's say, bigger. And now let's see what kernel objects are being built. Yeah, so now it's ARM. So I'm doing one by one. That's fine. Let's go back to where I was. And here, like under the output, let's see. We have kernel, Linux kernel install, which is fine. And we have under, I'll skip like the models now. And we also have, what's its face? And here I choose like the busy image like for the x86. And I also have, let's just run a RAM disk. This is good enough for testing like kernel. I can do also like with DRM and all kind of parameters, but now I'll just do the minimum, and that's it. It will work with DRM. For that I have like the scripts. I will not, if I put all the parameters, it will take me time now to remember where they are, and I just don't want to do it. I want to keep it shorter. So, okay, so we'll do like QEMU system. So this is like the kernel, and there is the init. I call it RAM disk. I tend to change it to init rootfs, okay? And so under here we have like the packed init rootfs, and we also have the content. So I can go ahead, repack it like with CPIO, okay? and maybe I can also call it cpi.gz. It's very slim, so I don't mind, okay? And once I do that, then it's not like a big deal. So let's, again, here we have under RAM disk something that is known. So let's do it, ls RAM disk in rootfs.cpio, just for the history. And we have ls kernel linux kernel install. I can also do build busy image. So I'll do dash kernel busy image dot, I think initRD or on disk, I don't remember the name. This fellow console dash append console equals ttys0. I'll do no graphics here. I'll do enable kvm, and I'll do QEMU system. It doesn't even matter which one. It's the first time I'm doing it, right? I mean, it's live. And it's good. I mean, yeah, well, I have like my RAM disk, but it's because you already know my installer. You already know like the different considerations. I didn't give like any params for almost anything. So if I look, I don't know, at Pro-K sound cards, then no sound cards. If I look at the sys kernel dr, okay, it doesn't even exist there because it's just not there, and it's all good. And if I go and exit the shell, it panics like every kernel. So we can do the exact same thing for every build, and then, you know, very fast, like take like this system and check that like the kernel works. You need any RAM disk, it doesn't really matter what. And as part of the builds, like you can then use more slim builds, which is what I usually do, but it requires some more configurations to add like to the general build. And you know, people who address these kind of things for the first time, I think that having minimum differences than the defaults is good. So if you can use the def config of like a new kernel to see what's going on, that's good. Just bear in mind that this is a release candidate kernel. So, I mean, once they are release candidates, they usually just work, right? But there are bugs. This is why they are release candidates. So all kind of like esoteric use cases are likely to not interest anyone. So I did not pause the video, and it's good that I did not pause it because I covered another topic. It's not so good for me because then I will not feel like updating the description or even remember what the descriptions are. So I'll just try to publish like immediately. But let's see which architecture we're building now. So I can go to the logs, or I can just look at the output. It doesn't really matter. Yeah, so I'm now like in ARM or ARM64. With the emulator, it also knows the device tree, so it's nice. So let's see if we, okay, so we don't have everything here just yet. So let's see. Yeah, I mean, it's not ready yet for the ARM64. If I went to build ARM, and it takes time. Like the first builds, when the kernel builds are relatively big, when the def config is relatively big, it just takes time. That's why when I want to build a lot of things, I use subset usually. Sometimes they require some adjustment between versions, sometimes not. And let's just show the ARM one. Let's see what's going on. We'll do QEMU system. I believe that resetting because of the no graphics is necessary. Resetting the terminal. So we'll do QEMU system ARM. And it's probably going to be image or Z image. Fair enough. I think I called the init fast the same thing. And console could be TTY0 or HVC0, I don't know what, or AMA0. Probably AMA0. Okay, I need to select machine in ARM. So dash virt or -cpu cortex something, otherwise we could have a problem. I cannot use KVM because I'm running x86. Okay, so it boots now, and it's of course slower, but it works as well. Okay, so same thing, just slower, and this pretty much covers it up. Let's see if we have now something new on the x86, on the ARM64. I want to look at the install. Yeah, I mean, it's still building. So we'll let it build, and that's enough for this one. I think it should be very useful because I showed like how we start from scratch. Before I talked about, okay, what happens when there are already caches. So when you do like your very first unpacking, it should be relatively easy for you. You will see the build scripts that are being used. I did, let's say, wrapper, debos, wrapper, all arcs. It's something quick that I wrote here for building Debian. I just set there are a lot of configuration variables, okay? But what I did for building Debian is build everything that is not from port and everything that is from port. But now I'm just building like a busybox for the kernel. I'm not taking care of like the imaging, just mostly wanted to see that the new kernel works, okay? So I don't need like any of this. And so, yeah, so I just did like a build for all the architectures, like chained. I put them in another directory that is this out tier that is, I just made like this code to write it and build busybox. Just say that the config is PscgBuildOS, the arc is arc, and the main idea here is like to test it, to quickly test the kernels. And I think I definitely showed it a couple of years ago in some meetup recordings or addendums. I absolutely show it in the PscG training, but I think that everybody should be already convinced that there is like a root file system that runs on busybox and it's equivalent in terms of the features that I said that the PscgBuildOS proposes to like the Debian ones, in terms of like checking, OTA updating, and all kind of things like that. And if you can save time on adding tools to the rootfs because you don't need them and just build the rootfs super quickly, then why not? Especially if you need a very, very small rootfs. So this takes care of it nicely, and this wraps up the video. I'll probably add more contents later.